or 4.5 in the book. By the way, this is day 1, which this has been split over 2 days. You're going to determine the horizontal, vertical, and obliques or slant asymptotes of a polynomial by analyzing the equation and using synthetic division. Okay, a couple of terms. Vertical asymptote occurs at any x value that makes the denominator 0. So this is after you reduce, so you have to factor top and bottom and reduce if you can, and then whatever's left over is going to give you a vertical asymptote. A vertical asymptote is an imaginary vertical line. A point of discontinuity is found by taking any part of the rational expression that reduces and setting it equal to 0. So this is going to happen, say you have x plus 1 over x plus 1. They can cancel out. And you no longer have the vertical asymptote, but you have a hole in your graph. And when I say we are referring to hole in the graph. And then your horizontal asymptote is going to be a horizontal line or an imaginary line that your graph cannot cross. And we have 2 tests really for it. When the numerator and the denominator of the rational function have the same degree, the horizontal asymptote is y equals a over b. So say you have 2x squared over 3x squared. Then your horizontal asymptote would be 2 over 3. Okay, when the degree of the numerator of a rational function is less than the degree of the denominator, the x-axis is the horizontal asymptote, so y equals 0. When the degree of the numerator of a rational function is greater than the degree of the numerator, there is no horizontal asymptote. Now, this is a special case because there's something else going on, but we'll talk about it later. Okay, so this is the first one. Determine the equations of any vertical or horizontal asymptotes. Okay, so if I was to step these out, the first thing I would tell you to do is, actually, let's do horizontal asymptote first. Horizontal asymptote. You're looking, it's all about the first term. And I have x squared over x squared, which gives me 1. So it's y equals 1. 2, I need to factor top and bottom. We need to see if we have anything that can be canceled out. So top is going to be x plus 1, x minus 1. And the bottom, we'll have a little bit more work to do. I need factors of -6 to add up to 1. And that's going to be 2 and 3. This is negative and this is positive, so the smaller gets the negative. So the factors on bottom is x minus 2 and x plus 3. Okay, so points of continuity or points of discontinuity. This would be where you can reduce. I know it doesn't say to find this, but you have to know how to get these anyways. And these are what we call the hole in your graph. Okay, so there's your horizontal asymptote. You have to factor to find points of discontinuity, and you need it for step 4, your vertical asymptote. After you found your points of discontinuity, set denominator. Equal to 0 and solve. So you have x minus 2 equals 0, which gives you x equals 2, and x plus 3 equals 0, so x equals -3. And there are your vertical asymptotes. Now I'm not going to step out these every single time and find this one first. Actually, it doesn't matter, but it's the easy one to find. Okay, let's try another one. Okay, so we have x cubed over 2x cubed minus x squared minus 3x. So on this one here, we need to factor top and bottom. So notice that there is an x in each of these. Oh, horizontal asymptote. Horizontal asymptote. X cubed over 2x cubed. Your x cubes are going to cancel out and you're going to be left with y equals 1 over 2. Okay, so factor. I have an x in the bottom, which leaves me 2x squared minus x minus 3. And on top, I'm going to leave it as x times x squared, because we need to talk about this guy. Okay, this one here is what I can reduce. It also becomes a hole in the graph. So point of discontinuity is at x equals 0. This is going to be, again, a hole in the graph. And now our vertical asymptotes. We have to finish factoring this guy here. So now I have x squared over, and I have 2 times 3 is negative 6 over negative 1. So this is going to give me, this is negative, so the larger of the two will be negative. Negative 3, negative 2. But because of this guy in front, I have to do the wagon wheel. Divide by 2, divide by 2. This guy reduces to negative 1. And the other guy does not, so he's going to come up front with the x. We get 2x minus 3. And if I multiply this out, I'll get this back. 2 times x gives me the x squared, 2 times negative 1, and oh, this guy was not supposed to be negative. There we go. Okay, 2x squared, positive 2, negative 3 will give me negative 1, and negative 3 and negative 1. Neither one of these reduces with what's left. So I have 2x minus 3 equals 0. So 2x equals 3, or x equals 3 halves. And x plus 1 equals 0. So x equals negative 1. And there are my vertical asymptotes. In the second part, we'll show how to graph these. Okay, another one. Horizontal asymptote. I have x squared over x cubed, which is going to leave me 1 over x, not the same power. This one being the variable. As x gets larger, my fraction, the whole fraction, gets smaller. So this is going to be the y equals 0. So now we'll look at point of discontinuity. Top part's going to factor really easy. X plus 2, x minus 2. And if you're looking at going, how do you do that so quickly? Negative 4. There's no middle term, so it's 0. Your middle term will be just x. And that's going to be negative 2 and positive 2. These two multiply out to be negative 4, and these two add up to be 0. So that's the top. But this one, we need to factor by grouping. So common factor here is x squared. And I'm left with x minus 2. And this parentheses, I need x minus 2 as well. So I factored out the negative 1. So we got on the bottom x minus 2 and x squared minus 1. And there's our point of discontinuity. They're exactly the same. So x minus 2 equals 0. So this is at x equals 2. And then the vertical asymptote set the remaining part of your denominator equal to 0. So x squared minus 1 equals 0. So x squared equals 1. Square root both sides. We get x equals plus or minus 1. And there's our vertical asymptote. Point of discontinuity, horizontal asymptote. Okay, these will never change. This is the only one that has different rules. And that brings us to the oblique asymptote. This occurs when the degree of the numerator is 1 greater than the degree of the denominator. Otherwise, there is neither an oblique or a horizontal. There can only be one horizontal asymptote or one oblique asymptote, never both. That's an important thing to know too. The equation of the oblique asymptote can be found by dividing the polynomials in the rational equation. The remainder will not be part of the equation, so once you get to the remainder, you can just stop. Okay, so let's get a couple examples of this. Determine the equations of any asymptotes. So let's look for horizontal. I have x squared over x, which gives me y equals x. That's not, and that can't happen. Anytime you get y equals the variable and no fraction, there's none. So y equals x is not a horizontal asymptote, so there's none. This is where I get to remind you y equals x. That means if x is 1, y is 1. X is 2, y is 2, so on and so forth. Okay, point of discontinuity. Factor these, but neither one of these will factor. This is not factorable. There are no factors of 1 that is going to get me to 4. And I don't need to worry about this guy to get this one because he's already factored for the most part. So there is none. And then we go to vertical asymptote. X plus 3 equals 0, so x equals negative 3. And because there is no horizontal asymptote, we go for the oblique asymptote. And this is where we have to use some synthetic division. So reminder on the synthetic division, all the terms have to be there. Degree 2, 3 terms, we're good. And change the sign on this guy to negative 3. Bring the 1 down. 1 times negative 3 gives me negative 3. This gives me 1. Negative 3 and 1 gives me negative 3. This gives me negative 4. This is my remainder. This is my constant. And this is my x. So this is going to be x plus 1. So my oblique asymptote is y equals x plus 1. And this is where I get to point out, notice we have y equals x. We just didn't have the whole thing. It's y equals x plus 1. But this, when you get the y equals x, that's telling you it's a horizontal, I'm sorry, oblique, not horizontal. Okay, let's try another one. Okay, so horizontal asymptote, again, just the first term, x cubed over x squared leaves me with y equals x. So no horizontal asymptote. Point of discontinuity. After factor top and bottom. So the top is going to give me a factor of x, and then I'm going to be left with x squared plus 2x minus 15 over x squared minus 5x minus 14. So we need to do this little x marks on both of them. So on the top one, negative 15 and 2 factors of negative 15. This is positive, so the larger gets the positive. 5 minus 3, 2, 5 times 3, 15. So I get x times x plus 5, x minus 3 over. And then the bottom one, negative 14 and negative 5. So the larger of the two gets the negative sign. 7 times 2 is 14. 7 minus 2 is 5. So we get x minus 7, x plus 2. But we can see we can't cancel anything out. So again, none here. but we're ready and set for vertical asymptotes. X minus 7 equals 0, so x equals 7, and x plus 2 equals 0, so x equals -2. Now, if you haven't figured this out by now, this is just your domain idea. All real numbers, except it cannot be these two, but what we mark them with vertical asymptotes. Okay, so now we have to go back to the horizontal, not horizontal, the oblique asymptote. Now here's the deal on this. This guy is x squared, so we cannot, and we already know neither one of these are factors of this. So we have to use long division on this guy. So we have x squared minus 5x minus 14 goes into x cubed plus 2x squared minus 15x plus 0. Okay, remember, 3, 4 terms. Okay, so if you still need to do the side work, this is x cubed over x squared, which gives us x. And multiply all of this by x, gives me x cubed minus 5x squared minus 14x. I will continue doing the change of color for when I subtract. Subtract here, they cancel. Subtract here, I get a double negative. So we get 7x squared. Subtract here, another double negative. So I just get negative x. And we bring our 0 down. And then we're doing 7x squared over x squared will leave me 7. So plus 7. So we get 7x squared, 7 times -5, -35x, and 7 times -14 is 98. Okay, subtract, those go to 0. Subtract, I get double negative. 35 minus 1 gives me 34x. And double negative here as well gives me plus 98. But this is the remainder. And we don't care about the remainder. We only care about this guy. So our oblique asymptote is y equals x plus 7. Okay, so I believe there is one more for us to look at, but I put in my notes that I want to do this one in class tomorrow. So we're going to work with this one tomorrow in class. But I'm going to go ahead and give the assignment so you can go ahead and start the assignment. This is actually day 2, so we're going to fill that out. And instead of odd, we're going to do every other odd. And that should help you guys get through the homework a little bit quicker, because everything we're doing in this section, you'll be doing in the next section as well. Okay, good luck.